So what I'm going to get you to do, this example, right, I've written this down at the top of the page for you. So for the first one here, I do just want you to watch what we're going to do, how we're going to solve this problem. So this is like a watch, and then the next one we'll go through together. Now we can see clearly this is a composite function. And what we're doing today then is we're differentiating, so you can have a look up here, we're differentiating composite functions. Now one way you could do this using strategies you already know would be to fully expand that, right? To do it to the power of 5, use your binomial expansion. It'd take a long time to expand it, and then we could differentiate term by term. That would be fine, it's just going to take a really long time. So instead we're going to learn the chain rule, which is a way we can differentiate functions like this quickly, one step. All right, so we'll build up to that, but for now we're going to take you through a sort of elongated process. What we need to do is we recognize this is the function, and we need to define it in terms of a composite function. So I'm going to let u be this part inside. 4x squared take 3x. Okay, if that's what u is, then y is going to be u to the power of 5. All right, you guys see that? If u is this, then I can define y as u to the power of 5. All right, now what I'm going to do, I'm going to write here the derivative of y with regards to the derivative of u. All right, so just like how we would have dy on dx, here I'm going to differentiate this, but with regards to u. Anyone want to have a guess? Using the power rule. 5u to the 5, it's going to become 5u to the power of 4. Very good. Okay? Everyone okay with that? We're just differentiating with regards to u. All right, similarly, we had u is 4x squared take 3x, right? And so I can differentiate this function u with regards to x. All right, and we're familiar with that as well. This would become 8x take 3. Good, very good. Now, watch this. If I have dy on du, this is the magic. Okay, this is going to blow your mind. Dy on du times du on dx. If I multiply this out, something can cancel. We've got du at the top and du at the bottom as a product. And so what are we left with? Dy on dx, which is the derivative of this function here, isn't it? So that means the derivative of y with respect to x is equal to dy on du, this part, 5u to the 4, multiplied by du on dx. Okay, and then all we need to do is substitute the u back in, because we want it expressed in terms of x. U we defined as this one. 5 times 4x squared take 3x, and then multiplied by 8x take 3. We'll wrap brackets around that. And so we're going to be able to move from here to here in one step by the end of this lesson. All right, so let me just explain, I'll run through that again, and then we'll get into those examples we do together. We define u as a composite function. U's the inside, right? 4x squared take 3x. We let u be that. We define y in terms of u. Differentiate y with regards to u. Differentiate u with regards to x. And then when I multiply them together, I'm left with dy on dx. So I multiply that by that. 5u to the 4 times 8x to the 3. And then I sub the u back in. All right, so that's the skill we're going to go through. Let's have a look at question 1 together. So all of that's already written down for you. You don't need to copy that down. Question 1, let's go through this one together. We have y equals 3x take x squared to the power of a half. Okay, straight away I'm getting rid of the root, expressing it as a power of a half. That power of a half applies to all of those terms. So, who wants to define u for me? What should we let u equal?
3x take.
Very good. 3x take x squared. Excellent. So if that's u, all right, then y is going to be u to the power of a half. Excellent. Now let's differentiate y with regards to u. All right, differentiating y with regards to u, we will have half u to the power of minus half. And we have u is 3x take x squared, so we'll differentiate u with regards to x. We'll have 3 take 2x. And then dy on dx is just those two multiplied together, isn't it? So we'll make the statement, dy on dx is half u to the minus half multiplied by 3 take 2x. And we want it expressed in terms of one variable, so we'll substitute u back in. Don't forget the minus half there. Okay. All right, so how do we feel about that so far? Not too bad. All right, so the next one we'll do will be a bit trickier. Okay, so we're going to use the same skills, but it's just going to be a little bit of a trickier function. I've got plenty of space. I'll just do it on the other side of the board. So we have y equals 4 on top of the cubed root of 2x take 3. Okay, that's the question, and I'm going to define it straight away in terms of powers, right? That is 4 on top of 2x take 3 to the power of a third, which means I can take it straight to the top as a negative power. 4 times 2x take 3 to the power of minus 1 on 3. All right, so that's all still the same function, right? All we've done is presented it differently. This is one way we can present it. Cubed root means to the power of a third. Take it to the top of the fraction, make the power negative. We're ready to go. Let's define u. Use the parts that's inside the bracket, right? So let's let u be 2x take 3. And so if u is 2x take 3, that inside part, it means y is going to be 4u to the power of minus 1 on 3. All right, and so this is how you check. If I put that in there, do I have my statement here? If I put that there, yes, they're the exact same. Now we can differentiate y with regards to u. Okay, the 4 is just going to hang out, and this is where we're practicing our simple differentiation. It's going to be minus a third u to the power of minus a third take away 1. Minus a third take away 1. Let's do that. Minus a third take 1. Need to have the same denominator. Minus a third take 3 on 3. That will give you minus 4 on 3. Okay, that's our power there. So that'll be dy on du. And then we differentiate u with regards to x. That'll just be 2. Derivative of 2x is 2. And now smash them together. Dy on dx is equal to the product of those. Now, you don't have to simplify it. Remember that? I've said you don't have to simplify it. I am just going to distribute this 4 in here just because it's going to be less ink for me to put on the board. So whenever we're multiplying fractions, that's going to the top. The negative's hanging out. Multiplied by 2. And so we can even write it as minus 8 on 3, and then the value of u, 2x take 3, is the power of minus 4 on 3. Okay. Anyone lost anywhere there along the way, or any questions to clarify? Okay, so then again, we will work through the rest of the exercise, but what I would like you to start with is question 3. Okay, so 2C.2, question 3, and we'll do at least A, B, C before I show you the super fast simple differentiation way of doing it. Okay, this process is important for our thinking and development, and then we'll look at doing it in one step. All right?
If you don't test, we have to know how to do it.
No, you don't have to know how to do it this way.